One of the smallest possible ring systems is found in the three-membered ring compound cyclopropane. Cyclopropane has the chemical formula C3H3. One of the features of this compound is that the bond angles among the three carbon atoms that make up the ring are so small at 60 degrees that we say the molecule has a very large amount of ring strain, making it incredibly reactive. Because of that, we had to construct special cards so that we can actually fit the atoms together close enough and connect them with the dots. Each carbon atom contributes 4 valence electrons. Each of the hydrogen atoms contributes 1 valence electron. Therefore, we have a total of 18 electrons in our system. We notice that by connecting all the atoms with single bonds, we are able to satisfy the duet rule for each of the hydrogens and the octet rule for each of the carbons. It's clear for this particular carbon, since we're using a standard card for it, that we're able to satisfy the octet rule, 2, 4, 6, 8 electrons. It may be not so obvious for the other two carbons that this is true, but I can show that 2, 4, 6, 8 electrons for this carbon. Then for this carbon over here, we have 2, 4, 6, 8. So we are able to satisfy the octet rule, which suggests we should have at least somewhat stable compound, even though we have to constrain the bonds in an unnatural orientation for us to do so. If we replace one of the carbon atoms from the three-membered ring in cyclopropane, we obtain the compound aziridine. Aziridine, since we've replaced one of the carbons with a nitrogen, is a heterocycle. To form the structure, we realize that each carbon atom is going to contribute 4 valence electrons. The nitrogen contributes 5 valence electrons, and each of the 5 hydrogen atoms is going to contribute 1 valence electron. Therefore, we have, just like for cyclopropane, we have an 18 electron system, and we're able to satisfy the duet rule for each of the hydrogens and satisfy the octet rule for the carbons and for the nitrogen atom. One of the things that we notice on the nitrogen atom is we satisfied the octet, but we also have here, as part of the octet, a lone pair. So we would expect that aziridine would be a base, which it is, but it isn't nearly as basic as ordinary aliphatic amines would be. If we replace one of the carbon atoms in cyclopropane with oxygen, we obtain another heterocyclic compound called ethylene oxide. This compound is so important that it is often known just by its initials as EO. Ethylene oxide is very widely used in industry as a precursor to form soaps, detergents, disinfectants, a huge variety of different compounds. Again, we recognize that we have a highly strained three-membered ring, and as a result, ethylene oxide is incredibly reactive and quite explosive. We can form the structure by, again, noting that each carbon atom is going to contribute 4 valence electrons. The oxygen atom contributes 6 valence electrons, and each of the 4 hydrogen atoms contributes 1 electron. Therefore, again, we end up with an 18 electron system, which we can satisfy the duet rule for each of the hydrogen atoms, and we can satisfy the octet rule for the carbons and for the oxygen atom. We end up, as pretty typical for oxygen, it ends up with 2 lone pairs on it, and we realize that to get this highly strained three-membered ring, as a practical matter for us, we have to use specially designed cards so that we can form this triangle where each of the bond angles is roughly 60 degrees. which is not what carbon wants to be. Carbon prefers to have bond angles of 109 degrees when it's aliphatic. Cyclobutane has the chemical formula C4H8. And in this case, we have a 4-member ring formed by the 4 carbon atoms. Each carbon is going to contribute 4 valence electrons. Each of the 8 hydrogen atoms contributes 1 valence electron. Therefore, we have a 24 electron system. And we're able to satisfy the duet rule for each of the hydrogens and the octet rule for each of the carbon atoms, using all the electrons without any being left over. In this particular case, we have a strange ring so that cyclobutane is reactive, but it isn't nearly as strained as in cyclopropane, so it's not nearly as reactive as cyclopropane. The compound cyclobutene has the chemical formula C4H6. We can see that it is the alkene relative of cyclobutane. We've replaced one of the carbon-carbon single bonds with a double bond. In this particular molecule, each carbon contributes 4 valence electrons. Each of the hydrogen atoms contributes 1 valence electron. Therefore, we have a 22 electron system, and we're able to satisfy the duet rule for each of the hydrogen atoms, as well as the octet rule for each of the carbons. So we see in this particular ring, 4-member ring, we have 3 carbon-carbon single bonds and 1 carbon-carbon double bond.